Hi, following up with the modeling of this project, we will see how to generate all these areas using the zonify command. Later, we will show how to use all the civil work commands to generate all these curves, rows of elements, individual blocks from the library, fences, paths, and stairs. Let's start by defining the zones of this project. I will use these 2D guidelines I have already created. Using the zonify command for this purpose, which can insert zones in two different ways. One is by picking a point inside an area. Make sure these areas are totally enclosed and that there are no gaps at the intersection of these curves. Or we can use boundaries. This way, we can easily pick these boundaries to define the zones. I'll move to the top viewport and click inside an area at the Pick Inner Point prompt. Then click here, and I can see the zone has been successfully detected. So now we can name it, select a hatch pattern for the 2D representation, as well as a material for the 3D representation. Then click OK. Now we get to define the insert point of the zone level. Let's go and select the zone now. Now go to the Lands Edit panel, and we can change any of its properties. For example, we could change the material by selecting another one from the library, or select one using the Layer option if you prefer to assign the material by layer. Also, the material assignment can be done from the Properties panel, Material, and here we can import a new material from Rhino's material library. I'll grab one from the Architectural folder, Floor, Terrazzo, this one for example. Now, if we unselect the zone and select it again, we will see the material assignment updated in the Lands Edit panel as well. Notice that when we select the zone, we could move its control points to edit it, or move the whole area using the gumball arrows. Let's undo this for now. We can also change the position of the labels by moving its control point at the bottom of the text. You can see that the zone is overlapping with the surface we had underneath. So I'm going to move it slightly downwards, say 1 centimeter, to get rid of the overlap. If we switch to the 2D representation, we will be able to see the solid hatch pattern we assigned earlier. The second method for inserting zones is by selecting this Boundaries option in the command line. Then window selecting the curves in this area. Let's select a different color. Let's say green. And we'll keep the grass material for the 3D representation. Let's call this lawn beds. Place it around here. Following the same process, we can finish all the zones of our project. Now that we have all the zones created in the project, we'll insert a few walls using the wall command. With it, we can define the height and the shape by selecting the curves. When we run the command, it opens a dialog box so we can edit the parameters of the wall. For instance, the thickness and height. In this case, I'll set the height to 1.2 centimeters. Set the justification to the left. Validate, and I'll pick one of these curves to set the wall path. This is my 2D view, but when I switch to the 3D view representation, I will see the walls in 3D. If we select it and go to the Wall tab, we can increase the smoothness, which will have an effect on the curved areas of my wall. We can also change the thickness, as well as the material under Materials tab. Here's a quick access to change the scale of the material. In the case of these curves, we will run the same command. This time, we will define a thickness and height with the same value. Then click OK. And now it'll prompt me to select the curves onto which it'll apply the settings we just defined. Another option is to copy properties of another object. We'll select them first, and then from the Properties panel, click on Match, then select the source object to match from. They will inherit the same material. Now that we've gone through the process of making wall objects from curves, we'll learn how to use the fence command to generate a fence around this playground area. I'll use this curve as a fence path. I need to split it at this point to exclude this extension. I'll run the split command and select the point option in the command line to split it where it intersects with the adjacent curve. Now, I can run the fence command. Fences are generated with posts, balusters, and rails. Here, we can control the general settings. We can choose to draw a post or not, the separation between balusters, their elevation, the dimensions of the rail components, and other settings. If we go to the Balusters tab, we can select a block from the library. Let's pick this one, for example. We could also browse for another block that we have as an individual file, or we can select a piece of geometry in the model. We'll find the same options for posts. Once we click OK, we get prompted to draw the fence using one of these options, or selecting a curve in the model, pressing Enter, and voila! Let's select the fence, go to the Lands Edit panel, and change any of its properties. For example, let's increase the separation between balusters. Or we can change the block used for the balusters. For this, let's create an element, for example, a cylinder. And in the Baluster tab, click Select to select the cylinder. So it will replace the previous block used for the baluster. Another option is to go back to the block library and select a different block. I'll delete the cylinder. As you can see, we have a full parametric object where we can control the settings of all of its components. We can also modify the fence's path by control point editing the curve used to generate it. Let's select this point, move it around. Let's undo this. In this part, I'm going to insert a few blocks from the Lands Design library to populate the project with urban furniture. Let's click on the library icon, which opens a block file explorer. Now I can navigate to the different folders that contain all the furniture elements that come in the Lands Design template. You'll find fountains, games, people, stones, urban furniture, water games, You'll also find a catalog of commercial products available in the market. In the top drop-down menu, we can switch lists to access other library folders, such as the Lands Design folder list, where all elements of other Lands Design objects are stored. There's the possibility of customizing the list by clicking on this button and adding a new directory here. Let's click on this new, give it a name, for example, Savannah 3D. Since I have the collection of Savannah 3D blocks, I'm going to browse to its location. Libraries, Documents, Savannah 3D, and click on OK. Now I can access all the collection of Savannah 3D models from the block library. Let's go back to the Urban Furniture Library. Select one of these games, let's say this one, and click on OK. Now we define an insert point and a rotation. Once an object has been inserted, the Edit panel shows the number of items which can then be selected by clicking in the list. So we can select it here and change the 3D block. Now let's go ahead and insert a basketball pitch. Let's click on the library icon again, select this block, and click OK. We'll insert it around this area. We can see the overlap between the beige surface and the basketball pitch ground. So, in this case, I'm going to detach these objects from the terrain so they don't snap to it. Clicking on this option. Now I can use the gumball to move it a few centimeters upward, say 2. In this example, we'll insert a row of elements by using the row command. Basically, it generates a row of elements that we can import from the block library. We can browse for one on our computer, or we can select an object in the model. Let's pick a bench from the block library. This one, for example. Under the Row tab, we can define the features for these elements. I'll set a separation of 10 meters between elements, and the offset to 0.5, for example. Once I click OK, I can pick a curve in the model as a path, or just draw it using any of the options in the command line. Using the polyline option, let's snap to a few points to define the row of benches. Here and here. Zooming in, you'll see the benches are not aligned as desired. So we can select the row, go to the Lands Edit panel, under the Sample tab, and click Tangent to Axis. Now let's increase the offset between the benches and the path curve by going back to the Row tab and setting a higher value under Distance to Axis. If you want to move it in the opposite direction, you need to set a negative value. For example, let's set it to -0.5, or even less. Looking good so far. Now let's learn how to alternate two different elements in the same row. I'll select my row. Under the Row tab, I'll combine two elements for this row. In the Edit panel, you'll see two items listed, each representing a separate row of elements. We'll select the first item and click on Block Library to change the selection for that row. I'll select a street lamp, this one, for example. Now the selected benches have been swapped with the street lamp. We can select the entire row back and edit any setting, for instance, the separation between items. In this part, let's populate a row with an element I'll create directly in the model. I'll turn on the layer with the arcs I will reference to create an extrusion object. Then switch to the top viewport. Run the cylinder command. We'll make it 4 meters high. To ensure this object will align properly with the curve, I need to create it along the x-axis. So I'm going to measure the distance between these 2 points. It's 9.4 meters. I'll copy this extrusion using that distance. And now I'll draw the beam using a box. I'll make it 20 centimeters high. I'll use the gumball to scale it a little bit outward. Now we can run the block command, selecting these 3 elements. Pick a point at the bottom of the extrusion as a base point for the block. Let's actually pick it from the top view, making sure project is on. Clicking on this point, and I'll name the block arc. Let's run the row command again. We'll click on select to select the block we just created in the model. Then we can edit the row parameters here. Let's just click OK. And we'll select this curve as a row path. So this is the result we get. To edit it, we can select the elements, go to the Lands Edit panel. The first thing we'll do is to align the elements in the right position. I'll go to the Sample tab, click on Invert to invert the direction of the alignment. Another option would be to invert the direction of the curve. By flipping its direction, it also flips the way the row orients the blocks. Now we get to define the number of items. Under the Row tab, see the number of units, set it to 8. We can, of course, increase that value at any time. For instance, we can double the amount of elements we have in a row. Let's delete the original block. We will no longer need it. Later, we can change the materials by editing the block and assigning the materials directly to it. I'll set this back to 8 elements. Let's create the stairs in this area using the path command. I could do it by extruding these contour curves, as I have done in this example over here. I prefer to leave the stair commands for more complex curved stairs. So in this case, I'm going to draw the profile curve of the steps in 2D and use the path command to extrude them along one of these curves. So we'll go to the top viewport. I'll measure the tread of the step using Rhino's distance command. So it's 1/2 meter. And now I'll draw a curve following these steps. We'll start with 20 centimeters for the riser and 1/2 meter for the tread. Let's copy it 3 times. And I'll draw a polyline to close this profile. We'll select all the curves and join them. This will be my path profile. We're now ready to run the path command. By default, it comes with a rectangular profile, but I'll click on Select to pick the curve we just drew. I'll make sure the justification is set to the bottom left corner and click on OK. And now we'll pick on one of these curves for the path. If the path is pointing in the wrong direction, we can select it afterwards. Go to the Lands Edit panel and click on Invert Curve. We can increase the smoothness using the slider to make it curvier so it follows the initial path. Another interesting option is the ability to edit the profile curve. So with the path selected, we can click inside Path and on Edit Selection Profile. Let's isolate this object to uncluster the view. This way we can access the profile and edit it by, say, moving the control points around, pushing and pulling. You can see how all the path object updates. Something to keep in mind is that a construction plane already aligned with this profile has been created. If we undo the changes to the curve, the custom C-plane subsists. It is important to set it back to the original C-plane. To this end, let's run the C-plane command. Click on World, Top. Now it's back to the file's original C-plane. I'll unhide everything again. Let's match it to another component so it copies a few properties. To do this, I'll go to the Properties panel, click on Match. I'll select this one as a source object, then validate so it inherits the same material and other properties. To wrap things up, I'll select this boundary curve and I'll extrude it 8 centimeters to finish this platform. I'll also match its properties from another object. If I want to imitate the texture mapping, I'll click on the texture mapping icon, click on Match Mapping, select the source object. Once I reopen the file again, the texture preview will be updated with the proper scale. To get a full preview of the furniture blocks inserted in your project, we can list them with the Listing command. You'll find it under the Documentation toolbar. We can use this command to list urban blocks. Inserting this list will show the amount of items for each block. Thank you for watching.